Howdy, students. So today I'm here with another question for y'all. We are asked to find the volume of the solid whose base is the elliptical region with the boundary curves 9x squared plus 4y squared equals 36, and the cross sections perpendicular to the x-axis, which are isosceles right triangles with a hypotenuse in the base. Okay, so first, I'm going to isolate y, because when we see in our diagram here, we are perpendicular to our x-axis here, and our base, in fact, is the hypotenuse of this triangle. Okay, so what I'm going to do, I'm going to move the 9x to the other side, giving me 4y squared equals 36 minus 9x squared. Dividing by 4 gives me y squared equals 36 minus 9x squared over 4. And then I'm going to square root this term, giving me y equals the square root 36 minus 9x squared over 4. Okay, because 9 is a factor of 36, I'm going to pull out a 9. Come on. 9, leaving me with 4 minus x squared over 4. Okay, I want to pull these two expressions out. Actually, what I'm going to do is I'm going to go one step further with this. And I'm going to actually pull out another 4 from here. So what we'll get is 9 times 4, 1 minus x squared over 4. Over 4. And so what we see is 9, 4, and 4 can all come out of our square root, or we can go ahead and cancel these two and just pull out our 9. And I'm going to do that, which gives us 3 square root 1 minus x squared over 9, 4. That's a 4. Okay. All right, so this is our y. Well, what is this? What is our y that we just solved for? What we just solved for is this length right here. But we need an additional y here. So I'm going to multiply it by 2. Multiply by 2. Giving me 2y equals 6 square root 1 minus x squared over 4. Awesome. The next thing we need to do is we need to talk about our isosceles triangles here. This is the y that we just solved for. This right here. This is y. This is y, giving me 2y right here. If we remember, the area of an isosceles right triangle is 1 over 2 base times height, or in this case, because we have even sides, even length sides, I can just say 1 over 2 times the hypotenuse squared. Nice. So what is our hypotenuse? It's exactly what we just solved for right here. So I'm going to go ahead and substitute this in, and that'll give me, apologies, backtrack just a second here. Remember, this is assuming we don't need 2, right? Assuming this is one triangle, but in this case, we need 2 hypotenuse. So I'm going to multiply this by 2, giving me 1 over 4 h squared. Okay, so now I'm going to substitute in this expression for my h. Therefore, we see that the area of one of our isosceles triangles that makes up the base of our region here is 1 over 4, 6 square root 1 minus x squared over 4. Squared. Awesome. So now I'm going to simplify this a little bit. I'm going to distribute this square, giving me 1 over 4, 36, 1 minus x squared over 4. I can divide these two to give me 9. Means our area is 9 times 1 minus x squared over 4. Awesome. So our last step is we need to find the volume. We have our area, so how do we find volume? We integrate. So now V equals the integral of 9, 1 minus x squared over 4. But what are our bounds? Well, if we recall, our expression is 9 x squared plus 4 y squared equals 36. Okay? If you notice again though, I have 36, 4, and 9. 9 and 4 are both factors of 36. So I'm going to simplify this expression. I'm going to divide by 9, giving me x squared plus 4 over 9 y squared equals 4. Dividing by 4 gives me x squared over 4 plus y squared. Come on, pen. Come on, pen. Over 4, 9 equals 1. Okay, so we see, back up here, given x squared over 4 plus y squared over 9 equals 1. If we were to square root this, we would get x over 2 plus y over 9, 3 equals 1. Right? This tells us that that the width of our ellipse from here is 2, and from here is also 2, but in the negative, and then our y from the origin is -3 down here, and 3 up here. So, because we're integrating with respect to x, our bounds are -2 and 2. -2 and 2. Alright, so let's go ahead and evaluate this integral. I'm going to pull the 9 out because it's a constant. 9, -2, 2, 1 minus x squared over 4 dx gives me 9. The integral of 1 is x. The integral of x squared over 4 is x to the 3rd over 12. Yes. Okay. Sorry guys, had a little typo in my notes. Just want to make sure that I'm not doing this wrong. So 2 plus 1 times 2 plus 1, which is 3. 3 times 4 equals 12. Cool. Alrighty. And then we have this expression, x minus x cubed over 12 on the bounds. Sorry, just tripped up about my typo a little bit. -2 to 2. So I am very sorry about that, guys. I don't know what happened, but it stopped recording. So let's walk through what just happened here. So we had our integral, right? We evaluated our integral here and here. I went ahead and applied the bounds, and then you'll see in red, here is x evaluated on -2 to 2, and then here is x cubed over 12 evaluated from -2 to 2. We see from the left-hand side that this expression yields 4, and we see on the right-hand side that this expression yields 4/3. So if we go ahead and substitute them back into our expression, this one here, we get 4 minus 4/3 times 9, right? I'm going to multiply the 4 by 3 so that I can have a common denominator, giving me 12 over 3 minus 4 over 3. And all I'm left with is 9 over 8/3. Right, so then I'm going to do the same thing I just did to the 4 to my 9. I'm going to multiply it by 3 so that I can have a common denominator, giving me 27 over 3 times 8 over 3. And I did that little math right here. And remember, when we're multiplying fractions, we just multiply straight across. Straight across. Right, so 27 times 8 is 216. 3 times 3 is 9, so we've got 216 times 9, which gives 24.